In this video, we'll see how a simple law of motion, that is conservation of angular momentum, decides the fate of the Earth-Moon system. We know that Earth and Moon are bound to each other by the force of gravity. The Earth spins on its own axis, which is called the spin angular momentum, and the Moon revolves around our Earth. Actually, they both revolve around their common center of mass position. But as the mass of the Earth is several times larger than that of Moon, so we can assume that Moon is revolving perfectly around Earth's center. The Moon is also tidally locked by the Earth's gravity. That means it has no self-rotation. Its one side is always locked to the surface of the Earth. So here we have a closed system, the Earth and the Moon system, with no external torque on it. So obviously, the net angular momentum of the system should remain constant. That is the law of conservation of angular momentum. In the absence of external torque, the net angular momentum of the system will eventually remain constant. So the sum of the angular momentum due to Earth's self-rotation and Moon's orbital movement around Earth together will remain constant. So scientists have made two important discoveries which help them to connect this conservation of angular momentum. The first one is they observe that Moon is gradually receding away from us, of course at a very slow rate of 3.48 centimeters per year. So every year the Moon is getting far away from Earth at a rate of 3.48 centimeters. Simultaneously, they observe that the Earth's rotation or spin is also gradually slowing down, losing 1 second every 50,000 years. So every 50,000 years into the future, the Earth's rotation slows down by 1 second. That means the length of the day, which is 24 hours, every second gets added to it. The days become longer. So the scientists initially wondered whether both these actions are interlinked. So let's see the cause from a detailed picture. So let's explore the fate of the Earth-Moon dynamics using gravity and conservation of angular momentum. So we know that gravitational force of Earth acts on Moon and that of Moon acts on Earth. This gravitational force of Earth on Moon is not uniform because the mass distribution of Earth is not uniform, at least on the surface. We observe that Earth is not perfectly spherical. The oceans bulge slightly due to Moon's gravity. So they become slightly closer to the Moon, very slightly. This bulge in turn attracts the Moon with a little greater force compared to the rest of the Earth. So in simple words, this oceanic bulge locks onto the Moon stronger compared to the rest of the Earth's surface. So now as the Earth rotates, this oceanic bulge also rotates along with the Earth, which in turn drags the Moon forward in its orbit, causing the Moon to gain speed incrementally. So Moon is continuously gaining speed in its orbit. You know what happens when an object in an orbit starts gaining speed? It becomes farther away from the center because as it gains speed, the orbit increases. So the Moon is slowly gaining orbital speed and angular momentum, causing it to move away from us at a rate of 3.48 centimeters per year. So according to the law of conservation of angular momentum, the net angular momentum of the Earth-Moon system should remain constant. So the increase in orbital angular momentum of the Moon causes a corresponding decrease in Earth's spin angular momentum. So the Earth's rotation simultaneously begins to slow down. Earth is transferring its rotational kinetic energy to the Moon. So Moon is gaining orbital kinetic energy. As the Earth's kinetic energy is being continuously transferred to that of Moon, its rotation begins to slow down. This action began billions of years ago when Earth and Moon were a single unit. So that time Earth was having a rotational speed of 4 to 5 hours. As the time passed, Earth's spin began to slow down with Moon departing from us. So into the future, after billions of years, the Earth's rotation eventually stops. So at this point, Moon becomes very far away from Earth. So in this process, we lose our Moon and also the Earth's rotation. But there's nothing to be worried about because this occurs after billions of years, even longer than the age of the Earth. But this is an interesting example of conservation of angular momentum, how it behaves in the cosmic scale in the Earth and Moon system. Thank you.